Hi everyone, this is Thiagarajan, retired Deputy Chief Engineer from Indian Railways. So in this video, let's say about coning of wheels in railway vehicles in Indian Railways. Okay. So what is coning of wheels and what are the advantages of the coning of wheels? Let's see. Actually, this is a picture shows the wheel set assembly where we can two wheels are there and both are connected together with an axle firmly fitted. Thereby the independent the rotation is not permitted. Okay, it's not like your road vehicles. Okay, and coming to the wheel portion, this is the flange. This is only the guiding the entire wheel set assembly to go in the right path. Okay, it's very important. And coming to the tire portion, this is tire portion. Actually, we used to say it's a tread, but it is not actually flat. Okay, it is kept 1/20 slope. So because of this provision of the slope, just like like a conical shape, so we used to say it is a coning of wheels. Okay, and because of the coning of wheels, actually the diameter of the wheel close to the flange will be larger than the diameter of the wheel at the edge. Okay. And so because of the coning of wheel, to match with this, the rail also kept inclined to follow the same slope of 1/20. Okay, and further the sleeper is such a way designed and is having the inbuilt slope of 1/20. So nowadays we have prefers to concrete sleepers of monoblock, and where the 1/20 slope is already it is inbuilt. Okay, in the sleeper. So when the rail is placed and fastened down, the track is assembled, this will be inclined to 1/20. So when the wheels are moving on this track, since the rail also having 1/20, this is also having 1/20 slope, there will be perfect contact, and thereby there will be uniform distribution of load will be there. The point contact is avoided. Okay. This is something about this wheel set and the design of our track to match our coning of wheels. And this is actually the gauge. That means the distance between the gauge face of the two rails. Okay, that means inner rail head to of one rail to other. That's called track gauge. Normally for broad gauge it is 1676 mm. But in case of wheel gauge, that is different. That means that is the distance between the inner face of the flange of one to other. That's called wheel gauge. So normally for broad gauge this will be 1600 mm plus or minus something. That means -1 plus 2, I think. Okay, that is a gauge, design gauge. And however, the contact point always, the contact point of the wheel with the rail will be, the corner of the flange. I mean, where the slope and the flange meets. Okay. So if you just to take the distance between these contact points of one wheel to other point, so that will come around some 1660. For example, this 1600. Maybe around is 30 mm will be there. So 1660. So there will be a difference of some 16 mm. That's called play. So always the play of 16 mm permitted. Okay. Always that the distance of between the contact point and the is always lesser than the track gauge. So because such a way designed to allow some play. When the play between the wheels and the rail is not permitted, what will happen? The flange will have the continuous contact with the rail in both sides, and because of the continuous contact, there will be more rubbing actions and lateral frictional resistance, and thereby there will be more wear and tear to the wheel as well as the rail components. At the same time, because of the persistent contact, see, in case of any misalignment, any minor defect in the track, like gauge variation and misalignment, there are chances for the wheel climbing over the rail and go out of path. So that is why some play is purposely provided for facilitating the and free movement. Okay, free movement. Let's see the wheel assembly also. Some of dimension also just you can see here. As already discussed, told this is the wheel gauge. This is 1600 plus 2 and minus 1. There is a variation permitted. And this is your wheel portion, and this 1 in 20 slope is given. Coming to the cross section of your flange and the thread, this is your dimensions actually. You can see here 1 in 20 slope is there, and from center of the thread and the tip, this is coming around 28.5 mm. That is depth of flange. At the same time, the thickness of a flange at the point where the curvature ends, So there it is 29.4. That is around 30 mm. That's what I told. So these are dimensions. So if you take 29.30 mm, 1600 plus 30, 1660 will be there when the flange having the contact with one side. The other side, there will be a clearance of 16 mm. Okay. This is something about the dimension of the wheel and the profile. Okay. Now we'll see about the coding of wheels. Okay. What are the advantages? Here, why coding of wheels? That for self-centering of vehicle as well as for smooth negotiation of vehicle on the curve. So how it's happening? Let's see. Suppose let us take a straight track. The trains are running on a straight track. This is a wheel set. Suppose for example, suppose because of some defect, some level variation or some gauge or some alignment defect, sometime what will happen? Always because of the play, it will try to go one side sometime. Always will not run center, and equal play will not be there because here some 8 mm and both side gap will not be there. Sometime because of the irregularity of the track, it may be the entire wheels will be shifted to one side. If that is what will happen, the flange will have the contact with the gauge face of the rail. Let us assume the wheel does not have the coding of wheel, just flat. Once it is flat, what will happen? Because of the shifting, and it will try to go over a long distance, and the wheel the one side will have the contact with the rail, and thereby there will be more wear and tear to the components, that is rail as well as the wheel. At the same time, any defect due to minor defect even, so it may not be able to tolerate, and sometimes even may climb over the rail and leads to derailment. So because of the provision of 1 in 20, so what will be the advantage? Let's see here. When the train is running on a straight track, okay. So because of 1 in 20, what will happen? As I told you, because of shifting of wheel set to one side, when the flange is having the contact with the gauge base of the rail, in this case, it picks up the large diameter. This wheel will be running on large diameter. At the same time, this wheel will be running in the smaller diameter, okay, lesser diameter. And because what will happen, because of running large diameter, this wheel will try to go forward than this one, and thereby the entire movement will be shifted towards center, go this way. Once it's going this way, automatically this will so large diameter will come into contact with the gauge face. So once it is taking place, what will happen? This will try to go forward, okay, than this wheel, and try to shift the movement towards inner side. Like that, whenever any flange, the wheel coming into contact with the gauge face, okay, after hitting that, it will try to go center only. So always, so there won't be continuous contact with the flange will not have the continuous contact with the gauge face. Once it just touching it, it will try to go center only. Like that, it's happening, and because of that, the there will be a free movement will take place like a floating and thereby there will be a jolly ride. Okay, so the wear and tear to the rail and wheel comfort also will be greatly reduced. Okay, this is a very good advantage, very good techniques have been introduced. Because of that, even straight track also is provided a lot of advantage. And this is called sinusoidal because the movement will take place, hitting and going this way, and again hitting going this way, like that. Just like the curve will be like this. You say it is sinusoidal curve. The path of the center of the axle will be like this. Okay, this is something about the sinusoidal motion or self-centering of the wheels, how it takes place, and okay, because of that, what all advantages we have. Okay, so okay, this is exaggerated anyway. Just you can see here, hitting it going this way, again large diameter picks, then goes towards center. This large diameter again this way, like that it's going. It's actually exaggerated animation. Anyway, this is the way the movement of the wheel, the railway of a railway vehicle takes place in a straight track. Okay, this is about sinusoidal motion. Okay, and self-centering of wheels. Okay, it is nothing but whatever I discussed. Put in the statement like. Okay, just you can understand. Okay, if whatever explanation it's not clear, you can just go through. Okay, you'll be able to understand, and even you can pause it and then can go through. Okay. Now wheels on a curved track. So already told, discussed. It provides the facilitate the two situations. One situation is when the vehicle running on a straight track, that is sinusoidal motion, that is self-centering of wheel. But whenever the vehicle negotiating a curve, okay, it's providing some advantages. How? Okay, so always whenever any railway vehicle travels on a curve, there will be centrifugal force will be there, and because of that there will be always there will be pull. Entire vehicle will be shifted. Try to shift the towards outside only, and also because of the change of direction and the wheel flange having the angle of attack. Every point, the wheel flange having the angle of attack, touching, and thereby the wheel is okay. The entire movement is following the curved path. So every point there will be angle of attack. So always the outer wheel having the contact with the outer rail cage face, always, as far as curve is concerned. Okay, and because of what will happen, so in case of curve, when it is traveling, when the movement takes place, the larger diameter coming into play always continuously. So once the larger diameter is coming into play, what will happen? Okay, this will try to go forward than inner. Actually, as far as curve is concerned, we want this one because in a curve, the outer wheel has to cover longer distance than the inner wheel. In a curve, from beginning point of the curve to the end point of the curve, if you take the outer rail distance will be more than the inner rail distance. So naturally, it has to cover longer distance. Because of the provision of the coning of wheel, to some measure we are able to achieve this one. And okay, so that we are able to avoid the resisted movement. Okay, so that this outer wheel is able to cope up with the movement of the inner wheel. Assuming that we don't provide the coning of wheel here, it is flat, what will happen? So in case of coning of wheel, there will be the movement and the toward radial position, whereas in the absence of the coning of wheel, if it is flat, it try to go parallel at the same time. See, this wheel will be lagging behind the inner wheel movement. Okay, so because of there will be resisted movement, and thereby there will be skidding and slipping of wheel, all those things will take place, more wear and tear, and at some time even it will result to some unusual occurrence also. Okay, so that is why the provision of coning of wheel is providing great advantages in case of vehicle when negotiating on a curve. Okay, so this is something about the the movement of the vehicle when it is negotiated in the curve. In what way the coning of wheel is helping. Okay. Then we'll go to the next. So whatever I discussed, I put in a form of statement here. You can just go through line by line. You can understand if it is not clear whatever I said. Okay. Then we will see something about the widening of gauge also, because normally in the sharp rocker we are providing some extra width we are providing, extra gauge we are providing. We used to say it is slack gauge, normally used to say, because in case of straight track, we used to ensure standard gauge of 1676, but whereas in the case of sharper curve, we are providing some slack gauge. Normally we will go up to some 10 mm like that is there. Okay. So why? Because of our so railway vehicle will have the two pairs of wheels. It is having the fixed base, but it is already straight. It is fixed in a straight position. But whereas in case of a curve, it is a curved alignment. So while negotiate in the curve, there will be restricted movement. Okay, and because of that, necessarily we must provide some slack gauge. Otherwise, what will happen? The front axle and the outer wheel having the angle of attack. Straight to that, the real if you take a rear wheel, rear axle, rear axle and outer or inner wheel, it will try to push. If it is not provided slack gauge, it will be in the contact with the gauge face. It will try to push the rail outward. Thereby there will be misalignment. The tilting of rails will take place. Okay, so necessarily you have to provide some slack gauge in the case of sharper curve. And further, some formula also is available, and using the formula we used to calculate how much slackness you have to ensure that. And also we cannot provide more slackness also. More slackness will happen, thereby the loss of the contact with the rail, and thereby there will be derailment. Okay, so it is all limited. So that also we'll see the coming slides in detail. So this is actually widening of gauge, slack gauge in sharp curves normally. Okay. As I already told, this is your front axle, rear axle. It is fixed. It is a wheel base. Okay. It is having the angle of attack, but whereas the alignment is curved, but our complete this the fixed wheel base having the straight position. When the angle of attack, when there is no sufficient gap, this flange of the rear wheel will try to push the rail outwards, and this wheel also push the rail outwards. Thereby there will be misalignment. So that is why some slack gauge is provided, that is being issued, and as per the Indian Railways schedule of dimension they are given. The sharper curve, how much slackness we are to provide, that also is there, that we will see. Okay. And also, in case of sharper curve, when the vehicles are negotiating, since due to the sharpness and fixed wheelbase, in order to guide the inner wheel, actually we are providing check rail. Okay, so that to avoid a sharp derailment in case of sharper curve. So we are providing check rail elements. Normally, check rail also we are supposed to provide when the curve is sharper. So as per the Indian Railway schedule dimension they are given some 8 degree or more if the curvature is sharper, but it's 8 degree or more, and we are to provide the this check rail. And further also we have some special slippers we have for provision of check rail normally. Okay, this is something about it. Okay. And again coming to the widening of gauge, how it is to be calculated, So some formula also is available. This is your extra gauge, how much slack gauge, how much you have to provide, that is D. That is equal to 13 into B plus L whole square divided by R, where B is equal to rigid wheel base for BG. Suppose we have taken worst case 6.1 meter, this case of 4-wheeler. So nowadays we are gradually reducing 4-wheeler also. We are having bogie type wagons only mostly. But even then there is for a safer side, This is your 6.1, that is okay meter for case of four-wheeler. Okay, this is, and R is the radius of the curve, and L is for lap of flange in meters. That is for that, the separate one relation is given, formula is given. That is point not 2 here. Here point not 2. So 0.02 into root of h squared plus dh. This formula is there for finding out the lap, and h equal depth of flange below the rail in centimeters. So already we have seen the cross section of our wheel profile, and there you would have seen normally 28.4 something, 29.4 was there, but sometimes in case of worst condition, worn out condition, it will even go up to 32 mm, I mean 3.2 centimeter. Okay. And these diameter of the wheels, normally some 1 meter diameter of the wheel nowadays, we have the 1 meter wheels. Okay, so this is something about the formula, and using this relation we can find out how much slackness we have to provide. Okay, this is related to the curvature, sharpness of the curvature. Okay, more the sharpness. Okay, so sharpness is more, automatically you will get a more this one, more slackage, like that. Okay. Then as per Shura dimension of Indian Railways, the gauge on straightened curves. How much is gauge normally? The allowance is given. See, in case of straight track, including curves up to 350 meters. Okay, so or more, 350 meters or more. That is flat curves and straight normally. As normal slipper we are using. That is slackness of minus 5 mm to plus 3 mm normally we are permitting. That is gauge in between 1671 to 1679 against a standard gauge of 1676. Okay, but in case of a sharper curve, it is sharper than your 350 meters. Okay, in this case we are permitting up to 10 mm. Okay, that is we are going up to 1686 mm against 1676 of 76 of standard gauge. Okay, this is about the Shura dimension provision as well as the gauge allowance is concerned. Okay, and minimum radius of the curve already discussed, 170 meters, the 10 degrees normally, but also we were supposed to, in the case of sharper curve we have to go for the provision of check rail as I discussed. Okay, if the curvature is sharper than 8 degree or more, if it is sharper, we have to provide check rails. In terms of radius, it is 280 meters or less. Okay, sharpness is there, we have to provide the check rail. Normally check rail, the minimum clearance we are supposed to ensure is 44 mm. But normally in case of sharper curve, and we are providing check rail using our slack gauge slippers. Such slippers are there, which is having the facility to provide the check rail also, that we are using, and we can adjust the gauge also there, the check rail gauge, clearance also we can adjust. And in that case, when you are ensuring the clearance, we must ensure the check rail clearance that will be equal to that 44 mm, that is minimum check rail clearance, plus of the slack gauge. Suppose 10 mm slack gauge you are permitting, of the slack gauge how much? 5 mm. So 44 plus 5 mm, 14 mm we must provide. Okay, that is the provision as per the Shura dimension is concerned. Okay, so this is about the minimum radius of curve, and when we have to use a check rail, when the sharpness is how much. Okay, and more sharper, and we go for the check rail. This is something about it, that is 8 degree or more. In terms of radius, it is 280 or less. Okay, however we have to provide a minimum check rail 41 mm, but it is based on your slackness also, slack gauge also. That is how much? 44 plus of the slack gauge. Okay, that we must ensure. Provide slack gauge slippers with the check arrangements. So it is all based on even speed concern. If it is warranted and even flatter curve, they may provide the check rail. And also, according to me, I think we have 4 drawings are there for slack gauge sleepers. So that will be based on your degree of the curvature. So according to requirement, you can knock on sleepers, you can lay. Okay, this is something about the sharper curve. So how it is to be managed. Now we will go for the worked out example, because this has been asked in UPSC Engineering Service 2021. The first question is something about superelevation that already we have discussed. So now this is current topic is this one, regarding the widening of gauge. This will try to understand, and we will make an worked out example. The wheelbase of the vehicle moving on BG track is 6 meter, the diameter of the wheel is 1.5 meter, and the depth of the flange below the top of rail is 3.2 centimeter. Determine the extra width required to be provided on gauge if the radius of the curve is 150 meter. But here 6 meter, it's first case I taken 6 meter wheelbase, and the wheel diameter 1.5 meter. Anyway, 1.5 meter is given. I think now we have 1 meter. Anyway, this is a problem. Actually, they give 1.5 meter. The depth of flanges below the top of the rail is 3.2 centimeters. 32 mm. Determine the extra width required to be provided on gauge if the radius of the curve is 150 meters. But normally, as the previous slides discussed, as far as BG is concerned, it has been restricted to 170 meter. We don't provide even siding. Normally the 170 meter and all. In case of space restriction, and mostly it will come in the siding, and important line. But mainly and all we don't go up to the sharpness. But however, it is restricted to 170 meters. 150 normally we don't permit. However, the problem they given 150 meters, then we can take it as it is, whatever they given as it is, and we can work it out. So for this, you see the formula already we have discussed. This is 13 into B plus L squared divided by R. First you have to find out the L. L separate formula is there, no? So using the relation, we find out the L, that is 0.44 meter. H is equal to, that is depth of flange, 3.2 centimeter, and D equal to 150, that is wheel diameter, we convert to centimeter, and 3.2 again the depth of flange centimeters. So relating, we are getting the L, lap equal to 0.44 meter. What is lap actually? Lap is the, see, whenever there is a front axle, the outer wheel will have the contact with the rail gauge face. The how much the width of the flange portion is having the contact. That's called a lap. That is being calculated using the relation. Using the relation L equal to 0.02 into root of H squared plus DH. So first finding out the lap, substituting here, so we get the value of this one. Extra width in centimeter is equal to 3.59 centimeter. So 13 into 6, that is wheelbase, fixed wheelbase, plus the lap, all are in meter, then divided by 150, that is the radius of the curve. That whatever answer we are getting in centimeter only as per the formula. So this is the extra width we are supposed to provide for this condition. But that means in mm it is coming around 35.9 mm. But as far as ISO is concerned, previous slide we have seen maximum plus 10 mm, 350 and sharper curve, we can go up to plus 10 mm, we can go. But here 150 mm the sharper curve, they gone, and for this they calculate. However, even though the 10 mm we are permitting, and after that we have some play also we are permitting. So already there will be play between the wheel flange and this one rail gauge face. That is around maybe some 16 mm, 16 plus 10, 26 mm. Even when we provide 10 mm, there will be a clearance of 20 mm will be there. However, as per this problem, this is the result. This is to be calculated this way. Thank you. This will conclude this video. Next video, I think I will try to put the leftover portion of the curve. Thank you.